Hello students, today we are going to look at volumes of composite prisms. That means that the cross-section of the prism is not basic figures anymore. So it's not just a rectangle, square, triangle, and so on, but the cross-section of the prism is a composite shape, a combination of several different basic shapes. So let's look at the first example. In this prism, the cross-section looks like an L shape, so the shaded pink face here, okay? So just to be clear, the very first step, which is very important in calculating volume of a prism, is to identify where the cross-section is, which face is the cross-section. So for instance, in this prism, the cross-section is not the rectangle here, because if this is the one, then the more you go up, for instance, making a cross section, at some point you will reach here, and then obviously the cross section or the shape is not going to be exactly the same anymore. The one on top here is smaller than the one at the bottom. So certainly this shape is not really the cross section. Meanwhile, if you take this L shape here, no matter where you are, if you imagine you take a knife and then cut off this figure along this shape, then everywhere you go from end to end, you will get exactly the same shape and the same size. So therefore, this L shape is the cross-section. Now you just need to find the area of that cross-section and then multiply it by the height of the prism. Sometimes we call this length instead of height, so it depends on the position of the prism. At the moment, the cross-section is here, the pink one, and from end to end, you have a certain distance, and that distance we call length or height. If I put this prism upright, so meaning the cross-section is on the ground at the bottom, then obviously this length will be upright, will be vertical, and then we call it height. So you don't need to be confused about it. As long as you know that you just need to multiply the area of the cross-section and by the distance between the two ends of the cross-sections. Okay, so let's try this one now. Since we see that this length is 20, and then you see all these signs here, we know that all of them are 20, then obviously this side here is 40 centimeter. And the height or the length here is 2 meters. So then multiply that by 100. 1 meter is 100 centimeter. Then we have 200 meters here as the height or the length of the prism. So let's first find the area of the cross section. We can split this L shape into two shapes. This one is a square and the other one is a rectangle. So then we have area of the rectangle, which is 40 times 20, and area of the square, which is 20 times 20. So we have here 800 plus 400, which is 1,200. Okay, and then the last step, you just have to multiply the area of the cross section by the height or the length of the prism, which in this case is 200 centimeter. So then in the end you have 240,000 in centimeter cube. Don't forget area as unit centimeter squared and volume centimeter cube. Right, the second example, we see here that the shaded face is the cross-section of this prism. So we just need to find the area. And we see that we can split this composite shape into two parts, a rectangle and a triangle. So in this case, area of the cross-section is then area of the rectangle, which is 4 by 9. And we add to the area of the triangle. Here is 5 and here is 4. It's not to scale. Area of the triangle will be then the base times the height divided by 2. So we'll have 36 plus 6, so 42 centimeters squared. And then the last step, to find the volume, we will multiply 42, which is the area of the cross-section, by the length or the height of the prism, which is 6 in this case. And we will then get 252 centimeter cube. Now in the last example, we see that the cross-section is like a rectangle with a hole in it. So in this case, we are not going to add later on, but we are going to subtract the area of the square in the middle here. So the area of the cross-section will be then 11 times 12, which is the area of the bigger rectangle, subtracted by 4 times 4, which is the area of the square in the middle. So here we have 132, subtract 16, so we have 116 meter squared, and the volume of the prism will be then the area of the cross-section multiplied by the length, which is the distance between one end to the next. And the final result is 1160 meter cube. So I think this is pretty simple. It's not so hard at all. You can try the question in the quiz and do the assignment of today. Good luck!